So going to simplify radical expressions. So if you recall, mention that if we have A times B or more terms that are in product without sums or differences, we can split them and write it as individual roots. And that is a rule that I went over. Now, the specific name for this rule is the product rule, which simply states if you have two individual roots, as long as the roots are the same, in other words, nth root, nth root, then you can bump them together. So whatever we learned earlier, we're just going to do it in reverse, and that's what the product rule is. If you have two roots in product, as long as the roots are identical, you can put them together and put it under a single root. Same logic applies with what we call the quotient rule. What the rule states is if you have an nth root divided by an nth root, as long as the root matches, you can combine them together and put it under one single root. Mind you, you can have any type of expression inside the roots. In other words, they can have x plus 1, x squared plus 1, doesn't matter. It could be any expression. And what we shouldn't get confused on would be to splitting the root when you have sums. So if I, for a case such as this, x plus 1 over x plus 2. There is nothing wrong with me writing it as x plus 1 over x plus 2. So this is perfectly fine, where I could have square root of x plus 1 divided by square root of x plus 2. The roots are identical. I can combine them together. But writing it this way is not okay. Sorry, didn't mean to do that. So splitting it that way is not correct. So that is something you've got to keep in mind. I'm stressing this time and time again because this is one of the mistakes that is very common when people deal with radicals. So the first thing to know here is that the roots are identical. Since the roots are identical, and since I have a product sign, I can combine the terms and put it under one radical. So for I have x cubed times x raised 7. Since the bases are identical, I'll keep x and add the powers. So 3 plus 7 would be 10. In a similar manner, suppose I have two separate radicals. As long as the root matches and as long as I have a product there, I can combine and put it under one root. So we would end up having 8y cubed. So since the roots are identical and we are multiplying, we will have the fourth root of ab squared times 27ab. 27, a times a squared, b times b squared, b cubed. So that would be the final answer. So we're going to use product, quotient, or both rules to simplify this expression. Numerator, we have y, and denominator 81 x raised 4. We can split it as square root of y, the fourth root, divided by the fourth root of 81 x raised 4. So fourth root of y, I can split 81 and x raised 4. That's the product rule. I cannot write y as a power of 4. With a power of 4. It's just not possible. You'd be going in circles because no matter how hard you try, the answer would always be the fourth root. But the denominator, though, you have 81, which is 3 raised 4. And I already have x raised 4. So those two would get cancelled. And I'd simply have the fourth root of y divided by 3 times x. So I can write this as 1 over 3x multiplied by the fourth root of y. So this is one of those examples where you were able to simplify some of the radical parts, but not all of them. And whatever part that we are not able to solve, we just leave it as is. I can also rewrite this in terms of a rational exponent, and that would be the final answer, because we know that the fourth root of y is simply y raised 1 over 4. So I'm going to split the root between the numerator and the denominator, and split the roots in the denominator as well. 81, I could write it as 9 or 3 cubed times 3. 3 cubed is 27, and 27 times 3 is 81. And then I could write y raised 12 as y raised 4 raised 3. I can split the denominator and write it as the third root of 3 cubed, third root of 3, multiplied by the third root of y raised 4 raised 3. The things that would get cancelled are the third root and 3 over there, third root and 3 over there. Nothing can be done about that. So we will simply have, third root of 2x divided by the third root of 3 multiplied by y raised 4. And I have a 3 where the root got cancelled there. So I have 1 over 3y raised 4. And in the numerator, I have a third root of 2x. And denominator, I have a third root of 3. Quotient rule suggests that I can combine the roots because the roots are identical. So I can combine and write it as divided by 3y raised 4 times the third root of 2x plus 3. So you may look at this problem and say, well, there is nothing I could do about that 7 because I have a cube root. So you cannot do anything as long as that exponent is less than 3. If it is greater than 3, you can do something with it. 7 here is clearly bigger than 3, so we can do something. I'll show you how. The negative outside is of no concern here. So I'm going to keep that negative out. Split the roots. And I can write 6 plus 1, which is the same as saying y raised 6 times y. That would be y raised 7. The denominator, I can write 27 as 3 cubed. Now, the cube and the root will get cancelled. We'll go to the numerator now. Split. And that's what I would have. The third root of y, now we can't do anything about it because the power of y is definitely less than 3. So we just have to leave that as is. But y raised 6, I can write it as y squared raised 3 multiplied by the third root of y divided by 3x. The root and the cubed will get cancelled. So I'm left with minus y squared, third root, of y divided by 3x. So the objective of this problem is to recognize that even if we have a term that will not be directly cancelled by the root, we should know how to manipulate that term. So the rule here is, as long as the power of whatever expression that you have is bigger than the root, then you can definitely do something to simplify. So we can split the terms. Mm-hmm. 25 is 5 squared. Square root of a squared. You look at b cubed, and clearly the root is not going to cancel the power 3, but I can write b cubed as b squared times b. I'm going with this approach because the power that is inside is bigger than the root. So I can split all the roots and cancel. So I'm left with 5ab multiplied by the square root of b. So the negative outside the root is of no concern to us. So negative square root of 32, square root of a raised 8, square root of b raised 7. So we want a multiple of 2 in the power of each terms. Square root of 32, I can write it as 16 times 2. A raised 8, I can write it as a raised 4 squared. I can write b raised 7 as b raised 6 times b. (16), I could write it as 4 squared. Unsplit the roots. I'm going to split the first radical. I can write b raised 6 as b cubed raised 2. And now I'm going to get rid of the root and the square whenever possible. It's possible there, possible there, possible there. So I'm left with negative 4 root 2 a raised 4 b cubed root b. So we know that we can combine the roots there because they are the same. So minus 4 a raised 4 b cubed square root of 2 times b. So that is the final answer. So we just have to be very careful in how we split the b's or the powers that are not divisible by the root. So here we have fourth root of 162 times x raised 7 times y raised 20. We want to know if we can write 162 in powers of 4. It's not possible. But I can write 162 as 81 times 2. X raised 7, the power 7 is not divisible by 4. But I can split it up and write it as x cubed times x raised 4. Y raised 20, the power 20 is divisible by 4. So I'm going to leave that as is. Now, could I, or is it possible to write 81 as the fourth power of some number? 3 raised 4 is 81 times 2 times x raised 4 times x cubed times y raised 5 raised 4. So instead of splitting each term individually, to save time, what we can do, this is just another way of doing it. It's entirely up to you which approach you want to use, because the preference varies from individual to individual. So I see 3x and y raised 5 share the same exponent. So I can combine them and write it as 3x raised 4, y raised 5 raised 4. And whatever that we left behind is 2x cubed. Nothing can be done about that. So now I can split and write it as 3x raised 4, y raised 5 raised 4, multiplied by 4th root of 2x cubed. The 4 and the 4th root and the power will get cancelled. So we would end up having 3x raised 4, y raised 5 times the 4th root of 2x cubed.